All right. Now, figure 2, let me draw that here. Because I want to talk about on, has everybody got this? Draw it right here, figure 2 right here. We've got a function that has a lot of hills, peaks, and valleys, something like that. Okay. Wasn't going to mention here the domain and range, but let me talk about another idea here, and that is increasing and decreasing, that they also pick up on some of these. The idea is pretty simple on the graph for a function to be increasing. For a function to be increasing, you're just going to go left to right, and the function is going to be going upwards. Okay. So as I go along here, of course, it's not increasing here because it's just flat. But when I hit this point, I'm going upwards, all right? So this piece right here would be increasing. Well, guess what decreasing is? Decreasing is if you're going left to right and you're going downwards, generally speaking, right? That's going to be decreasing. So it's not that difficult to see on the graph where it's increasing and where it's decreasing. Now, the reason it's called increasing and decreasing is because of this. Here's the kind of the verbiage is increasing on an interval I if the f of x1 is less than f of x2. Let's put it this way. F of x2 is greater than f of x1, where x1 is less than x2 on I. It gets a little, I said the picture's probably easier to understand than the words here, but this is what it means. When you're going left to right, that's what this means. We're going left to right. x1 is less than x2, so my x1 is here. My x2 then is, the x1 is less than x2, so I'm going left to right. What this means is then the f of x2, though, is greater than the f of x1. So it's increasing as far as the function value goes. The function value is greater for f of x2 than it is for f of x1. That's all that means. So it's increasing. It's increasing in that the function value is increasing. Decreasing is just the reverse of that. The f of x2 is less than the f of x1, so it's going downwards as far as the function value. So it's all based on the output values. Okay? Now, as far as designating it here, here's how we do this. We put this in terms of domain intervals. It may say give the interval for which, and the interval we're talking about is the domain interval, the x interval. Okay? Be aware of that. Okay? So where is this one increasing? Well, like I said, it's not increasing here. As we go to, get rid of that. Where does it start up increasing, would you say? Probably at 1, right? It starts increasing at 1, or just after 1, more specifically. And it increases all the way to 3. Would you believe that with me? So 1 to 3 on the x-axis, it is increasing. So it's increasing, and we just put it in terms of the domain interval 1 to 3. Now notice I didn't put brackets here. Didn't put brackets because it's actually at 1 and at 3, it's not increasing. And we'll talk more about this in a few weeks, but just be aware that you don't, on the increasing and decreasing, you don't include the endpoints. So use parentheses. Then at decreasing, it picks up at 3 and decreases to here, which it looks like there is, what, about 5.5? Yeah, that's about 5.5, not quite 6. So it's decreasing then from 3 to 5.5. And then we pick up increasing again. 5.5, it increases to, what, to 7? So this point up here, the peak, is where it increases again from 5.5 to 7. Got another increasing there. And then at 7, looks like to infinity, it picks up and goes decreasing. Because from 7 all the way out, it goes off the page there, so we'll call that decreasing, 7 to infinity. All right? Now, what about this part up here? Well, this part up here, it's not going up, it's not going down, it's staying constant, right? So this part up here would be a constant. The function here is constant from negative infinity to 1. I don't know if they'll ask about constant, but just in case, FYI, okay? Function is constant, negative infinity to 1. Okay? Now, just to be clear here, these are all based on the x. You don't put the function value here. That's one reason I didn't mark the y-axis, but even if I did, these increasing and decreasing parts are based on the x-axis, the x intervals. So be aware of that and pay attention there. All right. All right, so one other thing they might ask then is, let's go to this. Where is f of x equals x squared plus 6x plus 9 increasing? How would we figure that out? Since I haven't told you any other way, let's look at the graph, right? Let's graph this thing. And that's where our calculators come in handy. You can grab it by hand if you want to, but what does this thing look like when I graph it? Well, we got another parabola. I think, is this what it looks like? Somebody check me on this. Is that kind of what it looks like? Did anybody bring a graphing calculator today? Okay, I'll do it today then. Whoops. Yeah, this one was easier if I'd put it in a different format. Let's make sure. Yeah, okay, I was right. Yeah, this one, if you factor this one, it's x plus 3 squared. So that's how I knew it was. It's just x squared shifted 3 to the left. So anyway, where's this one increasing? Where would you say it's increasing? Negative 3 to infinity, yeah. It's decreasing till you get to negative 3, and then it turns around at negative 3 and starts increasing. So it's increasing negative 3 to infinity. All right, so if it asks one like that, just go with the graph. Now, figure 3, I give you that one because we're used to these smooth flowing functions, but won't always be the case. We may have in figure 3 there, I've got some sharp angled graphs. I guess I had one on that one too. But all right, so looking at figure 3 on the handout. Let's see, try to represent it up here. So at 1.5 we start, then it goes up to 2.4, I think. 2.4, and then it peaks out and then drops down to 2 at 3, and then it goes out like that. Okay. Well, okay. What would you say on that one? Could we do domain and range? And sure. Now this one looks like it has a starting point, but then it keeps going to infinity. So what about the domain? 0 to infinity. 0 to infinity. The range, well, this line doesn't drop any lower than that, does it? So it looks like 1.5 starts my range and it goes to 4. It's only, the y values are all between 1.5 and 4, isn't it? Is that what y'all say? Okay. And decreasing, so just do decreasing. Where would it be decreasing? Well, it's where it's down from left to right, 2 to 3, yeah. And again, on decreasing and increasing, don't include those endpoints. Those won't ever be included. It's always parentheses. Is that okay?